All right, class, today we're going to look at section 12.2, and we're going to look at this idea of completing the square. Now, we already saw yesterday that we're actually going back to chapter 5 and dealing with quadratic equations. And in chapter 5, we learned how to solve quadratic equations by factoring. Everybody in here was very good with x factor by the time I got done, and then we used zero product property, and we found our two x's. We found our we could solve for x squared. Now, sometimes though, back in chapter 5, when we got through with Xbox, it didn't work, and so we said it was prime. And so when those problems that we have are not factorable, then there needs to be another way to solve for x, and this is one of two ways that we're going to learn. Now, yesterday we talked about perfect squares, and we reviewed a lot about trinomial squares, and so that's what we're going to see today. We're going to get an equation and we're going to make it become a binomial squared, because once I get a binomial squared, then I know how to take it to the end and solve for x. So if you look at equation number 1, and I wanted to make that a binomial squared, what would I have to fill in for my constant term? Yeah, that's right. This would have to be 49. And we learned yesterday how to recognize that. The first number is a perfect square. Remember, we checked the middle with 2ab, so that's how we got the 7. Okay, 2 divided by 14 is 7, and then we squared it to get 49. So what would we fill in on number 2 to make this be a binomial squared? 100, that's right. And then how about for letter C? If I want to make this be a binomial squared, then I'm going to fill in 9 here, and then we would recognize, oh, those are my binomial squareds, and we would know what to do. So here's what's going to happen as we start out in section 12.2. We're going to start with something in quadratic form. There it is, ax squared plus bx plus c equals 0. It's in quadratic form, and we want to be able to rewrite it as a perfect square so that we can get something like this and solve like we did last night. So this idea of completing the square then is the process of changing something in quadratic form to something as a perfect square. Now, we're going to see, in order for us to do that then, okay, we've got to be able to take the binomial squared, this. So there's got to be a way to go back and forth. So if I look at this then on number 3, how are we going to do that? Well, some of you are going to look right away and say, this has to be 36. But let's look at how to do that. Now, the box that shows us how to do this in your book, it's a gray box. And so the first thing we're going to see is it has to be in the correct form. And the correct form for me to complete the square is this. I have to have the quadratic term and the linear term on one side and the constant on the other. If it's not that way, then we may have to rearrange the furniture, okay, rearrange the equation to look like that. Now, in order for us to find C, in order for us to find that constant term or complete the square, here's the equation. Okay, we'll find B. Remember, B's the number in front of the linear term. Divide it by 2 and square it, and then we should be able to factor and solve like we did last night. So let's do a couple problems together and see how it's going to work. If I look at number 1, well, it's already in the right form. Okay, I've got my quadratic term and my linear term on one side and my constant on the other. So now we need to find C. We need to complete the square. So I like to write it like this. Y squared plus 8y plus c, we've got to complete the square, equals 10. But now remember, back in chapter 3, whatever I added to one side, I have to add to the other because of those properties of equality. All right, now how are we going to find C? Well, remember, it's b over 2 squared. And if you look, b is 8. So we're going to have 8 over 2, which is 4, and 4 squared is 16. So we're going to plug in a 16 here, and whatever we do on one side of the equation, we have to do on the other. Now that we forced this, we made this to become a binomial squared. So how would we factor that? Well, it's going to be y plus 4 squared equals, and then 10 plus 16 is 26. So we took something, we made it become, we forced it to become a binomial squared, we factored it and got our binomial squared here, and now we just do what we did last night to solve these equations. Well, what do I need to do? I need to get y alone, but remember, y's inside that parenthesis squared. How do we get it out? Well, we got to take the square root. What I do to one side, I do to the other. So now I've got y plus 4 equals, remember, k is positive, it's greater than 0, so we have to say plus or minus the square root of 26. That's what we learned yesterday. And now y isn't alone yet. So who do I need to move to get y alone? That's right, 4. So we're going to say y equals negative 4 plus or minus the square root of 26. Now, believe it or not, that is your answer. Now, if you looked it up in the back of the book, they may have said this, y equals negative 4 plus the square root of 26, and y equals negative 4 minus the square root of 26. I'll take either answer. Now, 26 is in my square root. I can't reduce it or simplify it, so that's my answer. And since we're in Algebra 1 CP and we can't use calculators, you're going to give me the radical equation as your answer. Okay, that's our answer to problem number 1. Now, I know it looks kind of weird right now, but once you get used to it, it's pretty quick to go through. We've got to do a couple to train our brain. Now, let's look at number 2, and let's see. Is that in the right form to complete the square? Well, you notice, okay, I've got to move that 307 over. Remember, it's got to be the quadratic term and the linear term, constant terms on the other side. So the first thing we have to do is we have to add 307 to the other side, and 307 plus 8 is 315. Okay, so now we're in the right form. We've got our quadratic term, our linear term, and the constants by itself. Okay, so now we've got to complete the square. We've got to find the constant term. So, and again, what I add to one side, I add to the other. So let's figure out, what would C be? Well, once again, it's b over 2 squared. This time b is 6. So we've got 6 over 2 squared. And that 6 over 2 is 3. 3 squared is 9. So we're going to plug in a 9 there. What I add to one side, I add to the other. Now, we're going to take our binomial squared and factor it. And we're going to get C minus, sign here's a minus, 3 squared equals, and what's 315 plus 9? 324, I think. 324. Now, if we look that up on the perfect square chart, I'm pretty sure it's a perfect square. So again, we're going to take the square root of both sides, just like we did last night. C minus 3 equals plus or minus. Square root of 324 is 18. Okay, we still need to get C alone. So we're going to add 3 to both sides. So C equals 3 plus or minus 18. And this time, we don't have a radical expression, so we can go ahead and figure out our two numbers. Okay, 3 plus 18 gives me 21, and then 3 minus 18 gives me negative 15. And there's my two answers. So a little bit different plan, a little bit different scheme of things than what we're used to. But once we do it a few times, I think we'll be okay. Now, let's go ahead and look at the next problem, number 3. When I look at number 3, now is that in the right form? You've got to look closely. remember, for it to be in the right form, I need to have an understood 1 in front of b squared. So I need to divide everything by 2 so I can get this to be b squared plus 8b equals 2. Now it's in the right form. If you remember back on, let me find the right one. Okay, back here, wrong one. Okay, remember I've got to have an understood 1 in front of my x squared. So we had to divide everything by 2. And now I'm in the right form to complete the square. So let's find c, b squared plus 8b plus c to complete the square equals 2 plus c. What are we going to get this time? Well, we've got 8, that's b right there, 8 over 2 squared. 8 divided by 2 is 4. 4 squared is 16. What I add to one side, I add to the other. What binomial square is this? We've got b plus 4 squared equals 18. So 16 plus 2 is 18. Now we've got to get b out of that parenthesis squared. So remember, we take the square root of both sides. B plus 4 equals, remember, got a positive number in front of there, so plus or minus. Now, hopefully you realize that we can simplify the square root of 18. This would be 9 times 2, so we got 3 root 2. And now, just one more move to get b alone. So we're going to have b equals negative 4 plus or minus 3 root 2. That's my final answer. Since we don't use calculators in CP, you're just going to leave me the radical expression as your answer. Good job. Now, number 4. What happens if I throw in something like number 4? Well, it's in the right form. Quadratic term, linear term, constants on the other side. So we need to find c. We've got to complete the square. Now, let's look. It's b over 2 squared. What's b this time? Oh, wow. There's an understood 1. So we've actually got a fraction, okay? It's 1/2 squared, which is 1/4. What I add to one side, I add to the other. Now, how am I going to write this as a binomial squared? W plus, well, what was back in the parenthesis? 1/2 squared equals, now, I've got to have a common denominator before I can add 3 to 1/4. So we're going to make this 12 fourths. And so we would get 13 fourths. So we've had to throw some fractions in to see what would happen. Now, we're going to take the square root of both sides to get that w out of the parentheses squared. W plus 1/2 equals plus or minus. Now remember, when I have a fraction, it's the square root of the numerator over the square root of the denominator. So we've got the square root of 13 over 2. Again, the square root of 4 here is 2. One more move to get w by itself. W equals negative 1/2 plus or minus the square root of 13 over 2. Now, can I add those? They have a common denominator. You're right, they're not like radicals, so I can't put them together. One's in the house and one's out of the house. So that's my answer. Now, if you look it up in the back of the book, it may say this, negative 1 plus root 13 over 2. Either answer is fine with me. But that's the end of the story on that one. So sometimes b is a fraction and makes it a little more difficult. Well, we just go back and learn how to handle fractions like we did back in elementary school. Now, we've got one more problem we're going to look at. We're going to look at number 6. Now, when I look at number 6, we're starting with the fraction. Okay, we're starting with the fraction. So I think probably the easiest thing to do here would be to use elimination. Okay, I'm going to go ahead and multiply everything by 3. Okay, I'm going to multiply everything by 3. So now I've got 2y squared. That 3 is going to cancel there. Minus 3y minus 9 equals 0. So we eliminated the fraction. Now we've got to get rid of that 2 in front of y squared. Remember, it's got to have a positive 1 in front of my quadratic term. So now I've got to divide everything by 2. So I've got y squared minus 3 halves y minus 9 halves equals 0. And now we've got to move that 9 halves over. Remember, it's got to be in the right form. I'm going to go ahead and say plus c equals 9 halves plus c. Now, let's go over here and spend a little bit of time on trying to figure out how to find c. Remember, to complete the square, it's b over 2 squared. Well, when I look, b is actually a fraction. See it right there? So it's going to be 3 over 2 divided by 2 squared. Okay, ladies and gentlemen, we're dividing by a fraction right here, which means I've got to multiply by the reciprocal. So now I've got 3 over 4 squared, which means this is going to be 9/16. 9/16. Kind of rugged there, but again, important to realize when I plug it in the formula and divide by 2, I got to multiply by the fraction. All right, so let's take this and now write it as the binomial squared. We've got y minus, well, this is going to be 3/4 squared equals, oh, Mrs. Burton forgot to put 9/16 here. Because remember, when I add to one side, I have to add to the other. Now, I've got to change this to 16ths. So 16 divided by 2 is 8. 9 times 8 is 72 plus 9/16. So now I've got a common denominator, kind of long and drawn out. Here we go. 3/4 squared equals, now what happens when I add those together? What's 72 plus 9? It gives me 81/16. So it looks kind of nasty there for a few minutes, but everything kind of worked out nicely because now we have perfect squares. All right, so we know we've got to take the square root of both sides. So we've got y minus 3/4 equals plus or minus. And again, both of these are perfect squares. So we're going to get this plus or minus 9/4. We've got one more move to get y. So y equals 3/4 plus or minus 9/4. So what's going to happen with that? 3/4 plus 9/4 is 12/4, which gives me 3. And if I do the subtraction part of it, we've got 3/4 minus 9/4, which gives me -6/4, which I would reduce to -3/2. So that one was kind of rough, kind of tough, a lot of fractions. But again, once you are kind of sure in the method of how to put it together, we can throw those fractions in and still be successful. Great job.